So, in today's class, we're going to be talking about streams as our first thing. So, let's talk about streams. And let's get started. So, name chat class, let's say main. And let's add our main in there. Now, streams are a bit important. So, the slides I gave you from your presentation, they're pretty good. So the first thing is, what are streams and what do we need to do with them? Well, the fact is we need to store information that outlives our application. So whenever we have an application running, let's say inside my task manager, what applications I have. So let's say I have Chrome, I have IntelliJ and whatnot. Chrome is a good example. Or actually, let me start up an application, Firefox. As soon as I start up Firefox, it's going to hold on to all of my previous windows. And this is important because I want to come back to all of the windows I was working on, my information. It needs to hold on to it, right? Well, if he comes back every time with a new window, let's say, so where is new window? So if it comes back empty, I have to go find all of those and it becomes a bit of pain for the user. So a lot of times you need to store information for it to outlive your application's life cycle, right? So Google Chrome is running right now, IntelliJ is running right now, but at some points I need to lower them, such as this is my recording, OBS Studio, right? So comes in streams. In case of streams, we could write to a specific data source, it being a file, a database, I don't know, anything you could name of. We could write to it where the data is going to stay alive. So it's going to stay stored somewhere for further use. And at any moment we want, we could go read that data source and put it back into our program. So Firefox, Chrome, and all of those, whenever you start it, it will go read that file to see what you had open, what location, what were you doing, and try to reopen everything as you left it, right? And this is an important thing to do. And this could be more than that. It could be, you could keep, let's say, information about the user, what's his login, what pages he already visited. What if he was going through tutorials and you could say, well, he already seen these tutorials, he doesn't really want to know about them as much. So you put him at the latest tutorial he would left off. If he was watching a YouTube video, you would say, okay, the user Reza is currently at 10 minutes in of that video. The next time you come back, it'll show at that specific time rather than restarting completely. Right? So you want to have a better experience for your users, and storing that data somewhere where it outlives your application is important. Right? Now, this input stream and output stream, again, it could be anything. It doesn't have to be a specific storage thing. It could also be streams that you've been using, such as system in. So in this case, system in captures any keys coming in from the keyboard, right? This is how we did the scanner. System out goes and displays this inside the console. Right? And we could have done system.err where we would send it to the error console. We could have also output it to, let's say, the GUI. Cool? So there's a lot of input streams where we get data from a source, such as a console, such as a database, such as internet, anywhere really. And there's a lot of output streams where we display something, where we send information. It could have again been some server somewhere. It could have been the console, the GUI, so forth, so on. So knowing what input is and output is important. And there is two different ways we could send or store this data. One is the byte, which is the zeros and ones we see. This is more compact. You could store more for less space, let's say. And then there's the character. And the real big difference is when we save it inside the character stream, when we save it inside this Unicode or this letters A, B, C, D, E, F, G, the cool thing about that is it's readable, right? While zeros and one is not as readable. So when should you send byte streams or character streams is based on you. If I was to say I wanted to store, let's say I wanted to write something to my notepad. Well, in this case, when I'm saving it or when I'm writing it, I want to save it inside of a character stream as an example. Right? When I'm sending stuff to the system out, to the console, I want to send it inside character streams. Right? Or if I'm reading it, again, I want to read it inside character streams because it's something the user interacts with. But if I'm saving data inside of a file, now I kind of want to go bytes because it'll take less space. If I'm communicating with a server, well, there is no user involved in this case. I want to send through bytes because it'll take less amount of space. And at the end of the day, I could always convert that data from byte to character, character to byte. That doesn't really matter. What matters is understanding what do I need at that exact moment. Okay, and this is important to note. Any questions? So that was that. Before we could start reading, writing and reading from files, we need to understand, well, before we could read and write from streams, we need to understand how to manipulate files. Okay, so come in the file class. So the first thing we need to do is use this built-in class called file. So we're going to press enter. It's going to import the library. So we're going to say file on my PC. I don't know what it is, but we're going to build it, create it, so on. And what we need to do is say new file. Again, it's an object that's going to do all the stuff required for us. You'll notice that the constructor needs to have a non-nullable, so you can't have a null value here, which is a string path name. There's a few other ones, but we're going to ignore them. We could also give it a file, etc. It needs a path name to the file, where the file exists on your computer. Now, this is the part where it's a bit tricky. There's ways to fix this, but let's say in this path name, 1 second. If you give it this is going to cause you an exception, but let's say in this path name, depending on your OS, so Java is, your application is running on, let's say Windows, or it's running on a Unix-like system, such as, let's say, Apple, Macintosh, or Linux stuff, the path name would look different. So let's say on a Mac and so on, you would have a path name like this. Let's say home / reza / blah 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 documents / file name .txt, right? And if you were on a Windows PC, which I am right now, it would look like something, C : // We're doing this so the backslash is going to be avoided, right? If you remember, this is a, what was this called? An escape character, so it's escaping the backslash. So again, let's do something similar. Well, the path would be different, but let's do something similar to what we're seeing. Usually, actually, inside C would be users. Then we have // reza // documents oops, let's go back here, // file name .txt. So this is the first thing to note. So if you're inside of a Windows, you would have something like this. If you're inside of a Mac or any Unix type OS, you would have something like this. And again, we are using their OS, so we can't really dictate how we write it here. But there's a lot of classes that could make this cleaner for us, so we don't have to care for this. Cool? Any questions? Okay. So the first thing to note, this thing that we're seeing right now is called an absolute path, right? An absolute path, an absolute path is a path where I say from the beginning of everything, the root folder, the root file, which is inside Mac home, or inside Windows, it's the drive, where I say from the root location, go to the specified place, right? From the root location, go to users, go to Reza, go to documents, go to file name. This is called an absolute path, where I specify from beginning to end where it is, right? And then there's something else we have, is called relative path. Relative path, let's actually rename these. Absolute file on Unix. And this one is on PC. Relative path, on the other hand, let's rename this. Actually, I'll put both so you guys don't get confused why I removed one. Relative path, on the other hand, which is really nice, is actually we forget this. We're gonna just stay on this. Relative path, it says where we are currently, start from there. So starts from where the application is executed. Okay, executed. So in this case, we don't need to say C users Reza document file name. We could say something simple as dot file name. Okay, and you could ignore this absolute path step. So in this case, the dot represents the current folder, and this is important. So in this current folder, create me a file name.txt, and that's what file is going to do. So it's either going to open file name.txt if it exists, and if it doesn't exist, it's going to create a file named file name with the extension .txt. Cool. So let's run these two things. Actually, this one we're going to comment it out because that's a Mac. But this one, which is going to say C users, let's try to path it out. So on my C drive, go to users, it exists. Go to res, it's not Reza. Res. Go to documents. Do I have a documents? I have a big document, but I'm not sure if it's the same path. Res documents, capital documents. Let's not make a mistake there. Documents, file name.txt. So you know what? Let's go on. Let's do it here, okay? So actually, that's where it is. If I copy this path and I add it before this, you'll notice it's gonna do the same thing. It's automatically adding me the here. If I remove this and I do Control C here, and then I do Control V. Notice it's automatically adding me the double slashes. So this is an absolute path, creating me file name.txt at this location. Now, on the other hand, this one is saying take the relative path of my application, wherever my application is getting executed, and create me a file name.txt. Let's go ahead and press run. Let's see what happens. So in both cases, it ran, but none of them created. Okay, so this is not done yet. What am I missing? So I created the file. 1 second, I just can't remember. Well, actually, how about, I think the only thing is, it gives you the file and you need to write to it before he creates it. So we're gonna pass this for a second. We're gonna do that inside the stream. So before we get there, let's do a couple things. So the file object gives you a bunch of helper classes. So let's do some system.out. The first one would be, again, I gave you, I already gave you a PDF. Sorry, so let's say absolute, give me the, well, one of them would be, does it exist? Right? So let's say system.out. This would be absolute path, absolute path. What else can it do? Absolute path dot, it could give you the path. So if you start typing, so you could get the absolute path or get the canonical path. What is this? So here we do Control Q, we get a little documentation, and we could read what that means, right? So this means removing redundant names such as dot and dot dot from the path name. So dot is the current folder, dot dot is the parent folder. We'll come back to this. Blah, blah, blah. So we could try out these things. And what is get path? Converts this abstract path name into a path name string. That sounds cool. So we'll start doing that. And I could also say, is what I'm pointing to a file or is it a folder? Is. So is it absolute? Is it a directory? Is it a file? Is that hidden? Right? These are all stuff that's interesting. Is it a file? Cool. And let's go ahead, copy this, and do that for the relative. And run that. So notice, for the two things we created here, right, we're running the same stuff. For the absolute path, does the file exist? Well, not yet, so it's false. Get me the full path. Notice how it gives me the whole path towards it. And is this a file? Well, it doesn't exist, so it's going to give me false. Again, if we do Control Q, we could read the description. Now for the relative path, again, does it exist? No. Get the path. Notice that this one, relative path, it gave me dot / file name. So the relative path is, again, giving me a relative get path, right? So if I wanted to get a better path, we would say relative get. Now look at this. As I type in, I get the IntelliSense popping in. You could get the path, get the parent file, or get the absolute path. Let's check out that. Run it again. Notice the absolute path becomes something like this. So this is where my project is currently running. So whenever I create this file, it's going to be here rather than, let's say, inside this absolute. And if I move my project to a different location on a different system, the absolute path is not going to work because that user might not exist, that folder might not exist, but the relative path will always work because it's relative to where I am currently, right? Any questions about relativity and absolute? Okay. So first thing we want to do is to be able to write to these files. So there is many different ways we could write to a file. We're going to use one of them, right? So displays relative path, displays absolute. Okay, so let's go ahead and create these files. Actually, I'll do it right here. So to be able to create these files, we actually need to write to them. So this file thing is just trying to grab them, do them. It will kind of create for us, but what we need to do is we're going to use a stream. So in this case, we're going to use file writer. There's all different ones. So there's a couple things to, so we're going to give it a name. Let's say this is our writer. Let's say absolute writer. Okay, and you'll notice if I do Control P here, we have a lot of constructors here. Again, I could give it the file name, or I could give it a object file, which we already created, which is interesting. And notice the second constructor here, of the file, or even the file name, is the second parameter is Boolean append. So rather than rewriting the whole file, I could append to the end of that file, which is also interesting. So if I append, I don't specify it, it's going to overwrite the whole file, erase everything that was there, and add a new. And if I put append to true, it will write it to the end of it. We're going to try both of them. But for now, we don't have any files, so we could ignore the append. Notice that all of these constructors, so actually let's go ahead and add our file first. Absolute. You'll notice that all of these constructors are gonna throw us an exception, which is IO exception. This exception will happen if the name file, if the file is actually not a file but it's an exception. It's gonna happen if the file doesn't exist and cannot be created. So in this case, you don't have access to that folder. Or if the file is currently being used, so you don't have access to opening it. So remember, everything we have to give rights and whatnot. Sometimes a file, let's say like a good example would be a database. Only one person could manipulate the database at a time. So if the database is in use, well, now we don't have access to the database. So the same thing could happen to files as well. So we need to take care of this exception. So in this case, let's go ahead and just encapsulate all of this inside of a big try. Yeah, this too, I guess. And we could catch. And again, what we're gonna catch, well, it's gonna be the exception that's being thrown. We don't want to catch anything outside of that, because then we're not being specific and we might catch something that we shouldn't have caught, right? Again, think of the bath, think of the shower. We have a filter to let the water go through, but to block any big objects so our pipes don't get clogged. But if we block completely and the water doesn't go through, well, we have the same issue. The water is going to start rising. So our filter, our catch in this case, needs to be specific to the issue at hand. So IO exception. Okay, and what you want to do, whatever, you could say here, one of the issues. So in this case, this happens. The file might be a directory. This happens. It cannot create it, so it cannot create that file for whatever reason, maybe access right. Of course, we could always check the access rights, before doing this creation, but we're not, so this is why they create these exceptions. It could have also happened that the file exists, but we cannot open it. So this could have been because, let's say, someone else is currently writing to that file and we don't have the rights to that file. Okay, any of these issues would be this IO exception. And the cool part about having a real exception such as an IO is it's going to give you a lot of functionalities related to input and output. Okay, well, maybe not in this case. It's just stretching it, but yeah. Okay. So if we do IO exception dot, we could get stuff in there such as what's the cause, what's the message, the stack trace of it happening, etc., etc. Any questions? Well, okay, so now that we open the file, we open the streamer to write to it. Now we could start writing to our file. So we could say absolute writer, and we could say write. You'll notice that it's, again, overloaded, this function. We could pass it a C, we could pass it a character array, a string, a character array with a bunch of other stuff, and a string itself. So I like string. Let's start with that. So hello, I am Reza. Again, we're gonna do absolute writer. We're not using the file. The streamer is the one that's gonna allow us to write to it, do stuff to it. We're gonna say write other message, right? Absolute writer dot. So we have write. We also have append, right? Let's see if we do append this time, what happens. Yeah. And one last thing we need to do is you got to remember that even though your computer is really fast, it still has rules. So if someone has the file, let's say the notebook, or let's say something, the remote control to the TV, well, no one else can have that remote control to the TV. Otherwise, they would overlap each other. One of them is going up the channels, the other one's going down the channels. He can't do it because there's only one TV, right? So the file can only be accessed by one person at a time. So in this case, we need to close our writer. So rather than doing it here, a better place to do it is to do it in the finally. And we're gonna do absolute writer, which we don't have access to it. Let's put these outside. Refactor. No. So what we're gonna do is copy these two things, just put it outside here, and we're gonna put them as null. So now, here I'm opening the file to be written, and in the finally, I will go and close. You need to do this, otherwise issues can happen. So if it hasn't initialized, it's fine, but I want to make sure I close it either way. Okay, so this is giving me an error, so the only thing we could do is say, well, if absolute writer is not null, then do it. What's going on? Initialized. There. Again, another exception. What a pain. So you know what? Let's do it inside. Let's just do it inside here. I don't want to really delve into this too much. And we'll take off the finally. Usually you want to do it in the finally though, okay? I just don't want to keep on going out of track. I'm just going to stick to what we need to do. So we got to make sure we close it. Otherwise, no one else could write to the file, and the file is currently being held for the use of this, whoever it is. In this case, our application, right? So if we run it this time, you'll notice there are outputs again. If you look at it, at the absolute path, does the file, absolute path, does the file exist? True. What is the path? It's that. Is it a file? Yes, it is. Relative path still doesn't exist. Now, if we go to this directory, which I think we did, you'll notice there's a new text file called filename.txt. So if we open this file, if we look here, hello, I'm Reza. This is what it wrote to my directory. Hello, I am Reza. Hello, I am Reza. Other message, meow. So now I have the issue where it's not going to the next line even though it's writing text because there is no function called write line. Right? To fix this, what we need to do is to add a escape character, new line. Well, actually, I don't need the plus. I'm sorry. There we go. So now if I write to it again, first of all, we'll notice that the file, let's write it again one more time. You'll notice that the file is going to be replaced completely rather than appending to it at the end. Hello, I'm Reza. Go to new line. Other message, meow. Notice there's no new line there. So let's go add new line. I'll run it again. Hello, I'm Reza. New line. Other message, new line. Meow. Let's go do the same thing for, let's go copy this. Let's do the same thing for our relative path. We need to create, let's create a new one of this. And we're gonna say relative writer. Let's bring this down. And inside the relative writer, again, don't do copy paste because you're gonna make mistakes. And we're gonna close it. And inside the relative writer, let's see where the relative writer goes now. So you'll notice that when I did the relative writer, it still says the file doesn't exist. This is because the relative writer, we copy paste and we made a mistake. We passed it the absolute file. So this was wrong. So let's pass it the relative file on PC. This is why copy paste is a mistake, something bad to do. So now we see that both things exist. And if you notice, something popped up in my side here, filename.txt. Hello, I am Reza, other message, meow. Cool? Now, let's go back with this relative writer. Rather than just writing to this specified this specified file and replacing everything, I'm gonna set the second parameter, which is append, to true. And when I do this and now I run it, you'll notice that my file name.txt gets added more. So if I run it again, more. If I run it again, more. Okay? So now every time the application is running, it's appending to the end of my file. And this is important because let's say if it was data adding in, we want to add it at the end as we go along. We don't want to lose data, right? The moment we lose data, we're going to have issues. The user's going to be like, well, I already paid for this thing. What's going on? Any questions? So, this is pretty good. This is the first way to write to files. There's many other ways. There's other different types of streams. We've seen another stream which is called scanner to read files. We're actually going to use that to read these. We need to always give it a file. We could give it a path, but do the file way. It's much better. The file takes care of a lot of issues. Make sure the path is correct. Make sure if you need to do concatenation, you could do that with different functionalities it has. When we're writing to the stream, we could either write it and replace everything, or we could give it append it, so it goes at the end of it. Whenever we're writing to the stream, even though there's an append and the write, we notice that they're both kind of doing the same thing. They're both appending. Actually, if we do Control Q, writes a string, and appends the specified character sequence to the writer. In this case, for us, we notice that it's not really doing anything meaningful or different with the way we're using it. So we could interchange write and append at this moment. And something really important is we always need to close our writers at the end of all of this to avoid any resource leak. Such as we can't allow other people to write to it, so on, and other issues that may arise with it. So, having this done, let's go ahead and do something. So this is to write. So I'm going to go ahead and grab all of that. I'm going to give you all of this code. Extract method. write to file in multiple ways. Okay, so we're gonna add that to that, and we're gonna comment it out. So that was to writing to a file. Now I want to read from a file, and we have the again absolute path, which goes to our whoops. Where is my? Did I close it? Let me grab this 1 second. Which goes to this location, our absolute file. And I'm going to delete that one. We also have our relative, which is within our stream. So we could always use the absolute path or the relative path, whichever one, whichever one works for you. Okay, so that's up to you. Let's do quickly here. We're gonna go and talk about how we could read from one of those files. So the first read actually we could do is the scanner read. Right? And usually we would do something like this, new scanner, and we would give system.in. So we're basically saying in this case, go and read from the system stream. In the case, the system.in would be the console input. But this time, what we want to do is to read from a file. So rather than giving it a system.name, we're going to go ahead and create a file. We're going to say this file is our relative file. Again, give it a good name. In this case, I'm just doing examples. They don't really have any meaning. And I'm going to say new file. And I'm going to say this location. Remember that the dot means the current location. The dot means the parent location. Actually, we should have played around with this. Well, parent location means go up a level in the folders. Anyway, so in the current location, give me this file name txt. So there's a file in there with the extension .txt. Okay, so rather than saying system.in as the parameter for our scanner, with this time we're going to pass in our relative file. Let's see if I made a mistake here. So I gave it a file source. That's fine. So why is it giving me an error? So here, scanner now could give us a unhandled exception, which is file not found exception. Notice the name. The name tells us everything, and this is what's so important. So it could be that this file doesn't exist. So again, we need to try and catch. So in this case, the error we were getting was file not found. So file not found exception, file not found exception. You could have called this variable name whatever you want. This is fine for me. And we could have said the file does not exist. Okay? And again, if we wanted to add the variables here, these usually, this one. Usually they would give us some functionalities to help us with that. In this case, you notice it doesn't really do much. We could put this outside of our try, so we could have access to it in our catch. So something we could have done was, let's say, this whole thing, I put it here. And now I could have said the file, let's say relative file dot get file name, absolute get name, let's say. So the file get the name file name.txt does not exist. So give the user a bit of an idea, right? And I could have put all of this inside of a loop. So he could have entered the file name. If the file name doesn't exist, I'll give him a message, ask him again what the issue is. So let's say the file does exist, so the scanner is going to be okay. Well, then we could just do what we've been always doing, such as scanner get, well, let's say next, sorry. So we could get next words. So let's try this out. What are we going to do is system.out. So one line for each word. We could say scanner.next. Okay. We got to be a bit careful. We want to only do next until it has next. Otherwise, it's going to be blocked or waiting or something. So this is not a good thing to do. So in this case, it got the next one. Well, actually, the first problem is we only ask for it once. We want to do in a loop until there is words inside the file name. So hello is the first thing, but if you notice, it goes down nonstop. Right? So what we want to do is loop through everything that's inside this file. So what we're going to do is put it into a while because we don't know the amount of times we're going to do this. I'm going to say scanner, do you have a next? If you do, system.out.println scanner next. So now if we print it, it's going to be a long stuff. Right? It's printing every word that's in there. So if we go back to the file name, you know, hello, I am Reza other. Message, meow hello, meow hello, I am Reza other message, meow hello. Okay, so let's clean this up. Let's just erase half of it. Just keep that. Okay, so it's printing every word inside of a new line. So what we could do is we could say rather than printing every word, we could also say print every line. So does it have a line? Yes, it does. Print me that whole line. And now it becomes a bit better. And we could do something even further. We could, again, as we get the data, it's up to us what we do with the data. I might have not done much with the data, I'm just printing it out, but you could have done something more interesting. So let's say if we go back to that file name, rather than it being hello, I am this and that, it could have been the user's name. And then let's divide that. I'm using this little thing we call pipe. I can't zoom in further. So Reza is the first user. He has $500. And then he tried to withdraw money, let's say, and he tried to withdraw 50. The next is Reza. Now he has 450. Now he was just checking, right? And we could say here, check is, we get no value. So we're just keeping it consistent. Now the next one is Jason. He's checking his bank account. He only has $30. Now Jason, he has again $30. That's his current amount. He wants to deposit 500. Right? Now if we print that right now, it's not doing much. It's just gonna print exactly what we see on screen. But because I know the delimiters, what I left in there, I could do something more interesting. I could say, let's say I could create accounts for these people. So let's say I'm going to create a source. So I'm going to do it together to you. So let's say this is our account. And inside of that, for each account, there's going to be, as we see it, there's a funds and there's a person. So let's say public. I'm just going to make everything public because I'm a bit, well, let's make it real, okay? When I do something and I say it's because we're trying to aim for something else, you make that into a standard. Anyway, so we want to keep our attributes private, so public string name. We're going to create some getters for it in a bit. We want to also create some amount of money he has. So let's make it this time into int. Usually you would have this into a float. Actually, let's keep it float. So we're going to say how much amount of money he has inside his account. And when you start this public account, you must mention a name and you must mention an amount. And we're going to say this name, this amount equals, I'm a bit tired today, name. And also we're going to create getters and setters for these. So refactor, encapsulate fields. We're gonna create some, well, setter is not for the name, but for the amount we could, actually not for each. So we're gonna get the name, we're gonna get the amount, the set name, we're gonna set it throughout the constructor. So we don't wanna have a setter for that. We wanna only be able to set once. But the amount should increase, decrease, depending if you withdraw or deposit. So set amount is not a correct word. We could say deposit, and we could say plus equal. And we gotta make sure that the deposit, the amount is not negative, right? You can't deposit a negative amount. It would have messed up our thing. So if amount, I'm pretty sure I misspelled amount. I'm looking at it right now, it sounds really bad. So if amount is less than 1, return, okay? Usually here you would throw an exception, but for now we're just gonna avoid it. And you're also gonna do a withdraw. Oh no, it's 1M. Amount. Type would rename to. Anyway. And I'm gonna say if amount. Well, we don't want him to withdraw negative numbers, right? That's not good. So again, here you would have thrown new exception. I'm gonna say this dot amount minus equal amount. So we cannot withdraw more than what we have. So amount is less than 1, or amount is bigger than current amount. So if it's bigger than the current amount, it's not good either. Okay? Anyway, so let's set this up. So as soon as we read our file, we get the scanner next line, right? Let's erase this. Scanner dot next line, which we notice it returns us in a string. But the string class gives us a lot of functionalities. So let's look at those functionalities. We could get characters at, we could compare, we could concatenate, and is there something replace? Look at that. There's a split. And as we look into it, or we Google, can I split my string or whatever, we'll find this function. And if we do Control Q, it says splits this string around matches of the given regular expression. Okay? So give you an example. The string boo colon and colon foo, for example, yields the following result with the expression colon. So if you give it the expression O, it'll give you B, nothing, and this. If you give it the expression colon, it'll give you the words inside, right? So if you look at the sentence, if you separate it with the O's will disappear, and everything before and after the O's will become words. Same thing if you use the colon. So what we're gonna do is split, and we're gonna split it with our delimiter. In this case, our delimiter is this thing that we're using. And split is going to give us back a string array. Let's say values as an example. And now those values that I have, I know because I wrote it, I know for a fact that the first one is going to be the name. The second one is the current amount and what it's trying to do. Might not be the best idea or the best logic. The only thing is, it's mine, and I built it, and I know exactly the rules for my data. So, having this, having the values, I could now create an account. A new account, and I need to pass it a name, which we have values at position 0, Why is it at position 0? Because again, I built it, and the first thing in there is the name, Reza or Jason. And then I could say, comma. I also need to give it the amount. I could say values at position 1. Okay, but this is giving me back all strings. So I need to convert this into a float. So I would say float class. Parse this string for me, which is value 1. Right? The helper class, we talked about it in previous videos. So now this allows me to create a new account based off things I wrote into a file. And this is all random. It's my idea of how an account would be at this moment. Doesn't really matter. But we're not done. So from that amount, I need to withdraw 50. Right? So now the second string comes in. We could say if values at position 2 equals, let's say, withdraw, this word withdraw. 2 dot equals, ignore the case. If it equals withdraw, what do I want to do? Well, then I want to say that new account dot withdraw, I can't spell, and the value is going to be float dot parse float is going to be values at position 3, which is the last position, 50. Right? And if I did this correctly, I could now print out new account, get amount, and it should be 450 rather than 500. As an example of something you could do with this. Okay, and here I got a mistake. Says at line 15, I tried to parse something which was not a float. What was it I was trying to parse? I was trying to parse 500, but that was not a float. So just before this, actually let's start doing something. We're gonna do a debugging. So I'm gonna go on the end of this line. I'm gonna put a red thing, little breakpoint. I'm gonna click here to get a breakpoint. Then I'm gonna go run debug. See this little bug thing? I'm gonna click on that. Application is gonna stop here at this moment, and we're gonna see our values. So for now, I'm getting a value from the scanner, and I'm splitting it into multiple. So let's see what happens. So now if we look at our string values, well, it messed up because he gave me, okay, so if we look at our values, the positions inside is Reza the name rather than all the values of the array. So the split didn't do it correctly. Okay, the split is giving me every character. The problem is I split it with a string. I'm gonna do it, no, that was not the problem. What is this mistake? Okay, so what we're gonna do is we're gonna separate this into multiple lines. String the line, scanner dot next line, and then over here I'm gonna put it the line. So here the function, actually we're gonna still run it inside my debugger, but this time we're gonna see the functions one by one rather than putting them all together, right? So here when I get the line, I notice the line is correct. Reza 500 withdraw 50, one line. And here when I'm splitting it, now we see again the value is not correct. The split is not doing what it's supposed to do, or there is an error there. Remove empty branch. Oh, okay, so this was being used, and we want to, this has a second meaning, this branch. So what we want to do is escape that branch so we could use that character, which he wasn't allowing me to do. What's going on now? Why is it not letting me to use this? Oh yeah. All right, what's going on? Let's put our sample text. So our sample text is Reza 5. So already we see that our thing is not matching anything. If I put double, it doesn't do anything. If I put backslash, it says bad pattern, no matches, no matches. Okay, so this delimiter that we're using here is not the best one. Maybe we'll use something else, something we know for a fact is not going to be used. So I'm looking at my characters. Let's say this character. Why is it not giving me any match? Hey, is that... What the hell is going on? Okay, give me a second. Let's go do a quick Google search. Java. We're gonna do string split. Oops. So we come to a multiple of this. One of the ones I really like is Stack Overflow. We'll go check that quickly. Again, notice I'm not searching how to do accounts and whatnot. I'm searching how to split a string inside Java, and we could get something super easy.
Maybe, sir, just empty space.
Well, what I understand that it's not working for anything. So, okay, fine. Let's do an empty space. The problem with empty space, though, is inside files, sometimes you get Reza M, right? This, I was trying to use characters that for sure we're not going to use inside names, and we're not going to use inside anything else. I'm not using dots because it could have been 50-25 because it's money, right? But I don't understand. We'll try space just to see if it's going to catch the first one at least, okay? And we'll come. I don't understand why it's not working. The split should work. Oops. Run again. Debug mode. So the line is correct, and notice there's a space. But when I try to split it, it got this the space. Okay, so the space works. All right, so let's do. Let's end this for a second, and what are we gonna do? Let's use some different character. In this case, let's use space as he was saying it. And if we run our application, so now we get the correct amounts, right? If we look at, remember that all we're doing here is printing the new amount after doing whatever it was. If it's withdraw it. Else, actually, you know what? Let's make this into a switch. Switch. Let's get, fuck it, you know what, let's just do it. Oh. Sorry, I just want to go quickly. Let's grab this, and let's do deposit here. New account, dot deposit, float, parse float, and values at position 3. So if we did it correctly, whenever it's supposed to deposit, it'll deposit. Whenever it's supposed to withdraw, it'll withdraw. And it'll show us our final amount. So if we go back to see our file name, the first candidate, which is Reza, he started without 525. He withdrew 50, so his final result is 450. This result is just checking his value, so his value is going to stay at 450. Jason is just checking, so it stays at 30. This time he's depositing, it goes to 530. Cool? Any questions? So with the file streamer, there's a lot of different ones, depending which one you use. You could write into an ASCII value into this Unicode text, which is letters and whatnot, as we've seen here. You could have also written into zeros and ones, which would have been much smaller in file size. Again, it would have been written in byte, so it's not actually characters. And remember, if you remember correctly, every character takes an amount of space in bytes. So this is actually taking more space than it requires to, right? And reading or writing into bytes, you could actually specify your sequence of how the data is stored. And it gives you a bit more value to your thing. Other than just space, it also gives you a bit of information hiding, right? If I come and I go into the file system and I see you have a file name, let's say bank.txt, I could open it and I could read everything that says about your bank. Could have been some PIN code, it could have been how much you have, etc. But if this, and I try to open it, but it shows me, let's say, bytes, zeros and ones, well, I wouldn't make any sense out of it, right? And this is another aspect that we could get with writing into bytes. Cool? So I provide you some files to manipulate, to show you some manipulations. If you go inside the, if you go read into streams, there's actually a lot of different streams that exist. So let's actually do a quick Google search. So in Java, as an example, if we look at all the different streams, so whatever this one is, I don't want to really go into this. Let's go. I don't want to show you inheritance, but there's a lot of different variations of streams. So let's say input stream. So let's fudge it. Let's just go in there. So if we look inside input stream, you'll notice there's audio input stream, byte array input stream, file input stream, filter input stream, object input stream, piped input stream, sequence, etc., etc. And you could even create your own. Okay, so there's a lot of variations of this, and the fact is you're gonna see them, but they're all gonna be either byte stream or they're gonna be character stream. Okay, at least in Java. So that's it for streams. I'm gonna stop the recording there.